Today we're going to be talking about the correct way to load data from Excel into a SQL server. And no, we're not just talking about deleting a table, creating a table, and inserting data. We're talking about building out a full process in order to successfully merge the data and build out a slowly changing type 2 table. Don't know what that means? Don't worry, I've got you covered. We're going to be jumping in with a practical example. But first, let's set the stage and talk about the business problem that we're trying to solve here. So here is an Excel-based plan or budget for a bunch of Timex watches. And in this case, we're planning out two different metrics. We're planning out units sold and sales, and then we have every single fiscal period up here along the top. This is the kind of thing that you might see a demand planner for Timex, whose kind of watches these are, put together on their own. This is also the kind of thing that a business leader might ask you as a business intelligence specialist to put into a dashboard and track against. Once you have this plan loaded, it's not infrequent that planners like to update their plans. So they might come to you with a new plan, and they might say, oh, but then this new plan, I didn't really want to redo the whole thing. I just wanted to redo these two versions. So can you go ahead and can you update just those two numbers? And this creates kind of some interesting data challenges. You see, as the person who loaded the data, you probably weren't given actually that much time to put it into a dashboard. In fact, what you probably just did is you probably just created a SQL table and just bulk loaded the data in. So now that you're being asked to update the data later on, you need to either do an update statement or maybe re-download the old data, edit it, and then back upload it up, right? The process is really not great and it's not well built. Simultaneously, there's another challenge you might encounter. So let's take a look at what that one might be. You see, while you were building and maintaining your dashboard, the business decided they also wanted to maintain a target for sell-through percentage, and your table doesn't have a spot for sell-through percent. And oh, by the way, they also decided not only do we now want to include a budget plan version, but we instead want to maintain a new version of the plan called plan new, and this is the version of the plan that we want to maintain in the dashboard. And at this point, you as the business intelligence data analyst are just going crazy because you're like, I've deleted and reloaded this table 20 times, and you start to double check your work because maybe you're worried it has the wrong version of the plan in it, and it just becomes a whole mess. So how do you solve this? Well, we need to kind of translate this into business requirements, and we have a couple. The first is that we need a data structure. The data structure will need to be able to maintain and hold multiple plans, and it'll need to be able to store different metrics or KPIs that we might not know about yet without creating numerous null values in other columns throughout the rows every single time we want to add it. And then it also needs to be easy to join and easy to query in BI tools. So that's our data structure technical requirement. The other technical requirement that we need is we need to design a mechanism for loading data into the data structure that we just theoretically invented that can accept an Excel file, can accept either a full or a partial plan, and does not require fully truncating and reloading the table every single time we want to alter the data. Now, listing all that out, when I hear that, I think of two things. I think that we need a type 2 table and that we need to use a merge statement. So I promised that we'd cover what those are. Let's take a look at what a type 2 table is. So a type 2 table is essentially a table that whenever there's a change that's made to a row, instead of deleting that row, it instead inserts a new one and then marks the old one as expired. So what that means is that you have kind of all of the data that you might care about, and then for every single row, you have a effective date time, so when that record became the most current record, and then an expiration date time, as well as a current row indicator. So in this case, right, This row right here is the current one in this screenshot. Type 2 tables are really great because if anyone ever asks you, hey, could you go back to what the data was as of this date, you can essentially use these date effective and expiration times to recreate your data at any given point in time, which is super valuable. A merge statement is kind of like a combo update insert statement. What you essentially do is you define criteria or a join, and then you say, hey, if this row in my source table is already in my, or this row in my target table is already in my source table, and I found a match based on this join, go ahead and update this. And then if not, go ahead and insert this. So it's a super valuable piece of data engineering code because it allows you to essentially insert new records and update old records all in one statement, all without having to fully reinsert all the data and fully delete out the rest of the data, which is something that a lot of people that are more inexperienced tend to do. They tend to just do a full truncate and a full reload every single time they want to update a table with new information, and that's just not a best practice. So going back to our timex example where we had a theoretical plan, what did we do? Or how did I solve this theoretical example? Well, I created two Fabric notebooks, one for creating the type 2 table initially, and another for essentially doing the merge of new data into that table. And as part of those two notebooks, they also do some data transformations using Python. I'm going to review those notebooks with you here today. It should be pretty easy for you to take the code and translate it into another Spark, PySpark based tool, right? So for example, you could easily move these into Databricks, but you could also kind of take the ETL process plus the merge concept that we're doing and implement it into something like a proc in Microsoft SQL Server. So before we jump in, let me just kind of talk about what I did in these notebooks. So one, I implemented a type 2 SCD, right? So slowly changing dimension table, even though our budgets here are technically facts, to track plan changes over time. I essentially wrote with pandas some code to transform the data into a really narrow table with columns for time, metric, and plan version, which then means that all of my plan, metric, time combinations are essentially a single row, which allows me to join other tables onto those, and then also allows me to magically invent a new time period or a new metric and not have the table continue to get wider and wider and wider and create a bunch of null values for all the other columns. And then one kind of cool thing that I hadn't done was I created a UUID using UUID5 to serve as a unique identifier for each combination of metric and plan. You don't have to do that. You could just use a concat. And if you don't know what that means, don't worry. I didn't before I attempted this project, which means I might have done it wrong, but I'll show you some of the code and talk through it. But yeah, I'm pretty excited about this. It took me most of the weekend to write this code, so I'm excited to make this video, and I'm excited to show it to you. I think it's really cool. If you're an actual data engineer and not a business intelligence professional and you see something that I did wrong, let me know down in the comments. And all right, let's jump in and let's review my solution. Okay, so I did my best to comment this because I'm going to leave it linked down in my GitHub, down in the video description, so you can download it, which is one of the reasons why this took so long. But first, imported the packages that I needed. So I needed pandas, numpy, UUID to create my ID, and then SQL data types from PySpark. So first, I'm loading in the Excel file that I've moved over into the resource section, right, of this notebook in Fabric. I'm reading it into a pandas data frame. I'm looping through and essentially replacing rows or cells that are only white space with null. I'm then dropping all rows where it's null. And then I'm using this really cool function in pandas called melt to essentially transpose any data that's not in my plan version, model, or metric column. And then I'm looping through the columns, making them all lowercase, replacing spaces with an underscore, and I'm changing my time period column to a string. So let's take a look at what my data looks like when I run this. So first I'll run my imports. Then I'm going to add a display down here, and I'm going to display my data frame. And here we go. So if you noticed, it's now transposed that Excel file that I had initially. And remember, this is my Excel file, right? It's now transposed it into a really narrow table. So then I can go down to step 3, which is where I am creating my unique identifier. I'm also adding on a record start, a record end, a transaction type of insert. I'm setting the active record flag by default to be true. I'm then creating my UDID. And so the UDID needs a namespace, which is essentially something to encrypt with, right? And then it encrypts your text. So in this case, right, I've concatenated plan version, model, metric, and time period together, and then I'm converting them to a UDID using UDID 5, right? And a UDID 5, if you give it the same text and the same namespace, it'll always create the same ID. So I'm using that to create a column called ID, and then I'm essentially moving that ID column over to the front of my data set. So if I now run this, right, and I go right here, and I run this, what you'll see is I now have quite a few more columns. So I now have a unique ID column. I now have kind of those columns I had originally, and then I had my record valid start, record valid end, insert, and a type true. So since this is the step that initially creates the table, I now have step 4, and oops, I didn't have a comment here. So I am creating a Spark data frame, and I am actually defining my Spark's data frame structure here, because sometimes Spark infers data types wrong if you don't actually give it a structure. So here I'm defining it, giving it the structure with all the data types, creating a Spark data frame out of my pandas data frame, and then finally I am outputting that Spark data frame to a table named targets, and it's creating that in the linked lakehouse that I have on this Fabric notebook. So hopefully that makes sense, right? And is pretty straightforward to you. And again, this code will be linked as well as the next notebook that I'm about to upload on my GitHub down in the video description. So let's now look at the other notebook that I created. So this other notebook right here is essentially the same thing, right? Except I'm importing one new package. So I'm importing date time. So I'm doing the exact same stuff that I just did. So I'm importing the notebook, right? I'm then adding on these new columns. So I'm doing that exact same thing, calculating the unique identifier. I'm then loading it into a Spark data frame, only this time I'm creating a temporary view called targets update. And then I start to move on to some new steps. So the first new step is I create a variable called record update time, okay? And I set that time to now. I then define a SQL query. So I essentially say, use this SQL query, this first part, to identify the records that I am going to need to be inserting, right? And then the second part, I identify the records that I'm going to need to be updating, right? Right down here, and I union them together using a union all. And I set the record start here to that record update time variable. So I'm using string interpolation to essentially, or formatting to essentially insert my Python variable directly into my SQL query string. I'm then executing that SQL query string using Spark and then writing it to an actual table called target staging. And that's because Spark uses this thing called lazy execution, which means if you don't actually physically write the data, as you make changes to it, the data might change as you go through. So when you're working in Spark, if you need data as of a given point in time, you actually have to generate the data. You probably don't have to do this as a table. You could save this as a Parquet file, for example. But then finally, right, so I now have my targets table and I now have my targets staging table. I then am actually going through, here is my merge statement. So I'm essentially saying, hey, if the record is in my targets table and my target staging table and they share ID, right, and target staging has a record transaction type of update, so you then set the old records flag to essentially the record end date equal to essentially record update time and the active record flag to false. And then I'm inserting all my new records. And then finally, I'm dropping my staging table. And let's take a look at what that looks like here. So here, for example, is an update that I made, right, for this record, just for this video. And as you can see, here's my ID, right? Here's the original record. And when it ran, right, it set the active record flag to false. It updated the record end date, and then it inserted in my new record. And all this runs fine. So I'll go run this through, and you'll see it'll start going through and connecting, and it'll run through. Cool. Well, with that, you've reached the end of this video. I hope you're as excited about this as I am. I know I personally was, I got excited about it. I spent the weekend playing with code, which is why I didn't release as many videos as I normally do. So I hope you like this video. I hope you watch it till the end. If you want more content like this, like the video, subscribe, leave a comment saying, hey, please make more content like this. Just something to let me know. And thank you for watching. I'm on my path to 3,000 watch hours. So if you made it this far and you watched the entire video, thank you. You really helped me out and helped the channel grow. Cool. I hope you have a good evening.